Aubrey, are you ready? Let me know when you are. That may not happen in the next 30 minutes. But any others? Three. Okay, so let's start with 3, then we'll go on to 4.
Oh my god, Tim Burton's alive though.
Who?
Tim Burton.
Oh, Tim Burton. Oh.
So for number 3, you would need to distribute. Nightmare Before Christmas.
Yeah, the Nightmare Before Christmas. Corpse Bride, I think.
Combine your like terms. If you remember what this is by just from this, you have the same coefficient and different constants.
Is it no solution?
It is no solution. But if you didn't and you kept going, let's say you got rid of your 7x's, you would get 2 numbers that don't equal each other, which would also be no solution. Questions on that one? Or we're finding the domain. So furthest left to furthest right. So we would start at -1, and it's going to keep going to the right. So that would be everything greater than or equal to -1, or starting at -1 and going to infinity. This is good that you chose this one, because this is what we're going to be doing today. A lot of domain and ring stuff. Aubrey, you can either try to figure it out on your own or come take notes while you're waiting. Go to the bed. Look at your course calendar. We're going to talk about some important dates.
Does this quiz we took last class go for next quarter?
Test.
Or this quarter?
The test is the last thing that goes in March period 3. So I graded them, but I literally finished them at the start of 7th period, so I have not put them in yet.
Okay.
So those will go in today or tomorrow or Friday, and then I'll be sending out progress reports so you can see what your final grade would be, unless you retake, finish Unit 7 tests, or turn in missing contents. So there's that. I talked about the Khan Academy quizzes that are up now that'll be due next Friday. Those will be the first grades of next quarter. Make sure you get those done.
How many are there? 2.
So make sure you get those done. Up until spring break, we are going to be working through this unit. Really continuation for the next 2 days of our next lesson. But Thursday is our flex day. Thursday is also the last day I'm taking retakes, retake work for retakes, missing assignments, missing tests. All of that has to be done by Thursday. So if you are missing Unit 7 tests or haven't finished it, I would not wait until next Thursday, because if you do that, you'll not have a chance to retake. That will be your grade, that's it. So come see me before, after school, come get that done. You may have time in class today. I don't know about Friday, probably Tuesday, but I don't know. Then when we come back from spring break, we'll continue this unit. You'll still have Khan Academy quizzes. The 19th of April would be your next flex day, which would also be your review day before your quiz and test. Yes. The 4th, the end of the year. But I'll have a deadline before finals for that stuff. Questions on any of that? So you should all have these notes in front of you. Josie. I'm gonna write some stuff off to the side for things we need to know and remember. So as we've been doing short breaks all of this time, anytime we did a domain and range, I've been saying this would be helpful for when we go to do it later. When we were doing quadratics and we were doing domain and range, I said it wouldn't be tested, but it's good information to know for later. And then, but way back when we were doing inequalities and we learned interval notation, all that stuff is kind of coming back for today's lesson. So off to the side, I'm going to write these notes so that you remember. When we have strictly less than or strictly greater than, we're going to use parentheses. Less than or equal to or greater than or equal to is going to be square brackets. If it goes to positive or negative infinity, we're going to use parentheses. Make sure you're writing this down. So this first set of examples is a bunch of set builder notation. We're going to convert it back to interval notation. So when you are writing this, you have to be thinking about where does this start, where does this end. So x is greater than negative 3 would mean it's going to start at negative 3. We have strictly greater than, so that's going to be a parenthesis, negative 3. Where would that end if it keeps going to the right? Infinity. Which would also be a parenthesis. That is not a great. So then for the next one, x is less than 8. Where would that start?
Infinity.
Negative infinity. Yes. And that would end at 8. Would that be a parenthesis or a bracket?
That would be a parenthesis.
Question so far?
This seems a little too easy.
This is like the basics. It gets like a little bit harder, but not that much harder. We're just using this on graphs, really. For the next one, how would we write that? X is less than or equal to 2.
So we're going to be...
We are going to use a bracket, but where would it start?
Wouldn't it be just the parentheses starting off?
It would be parentheses to start off because where does it start?
Negative infinity.
Negative infinity. But then it ends at 2, which needs a bracket. So sometimes you'll have a mix. The next one. So if you kind of have to imagine a number line when you do these. If x is less than 2, less than or equal to 2, I have some closed circle at 2, I have some arrow going to the left, and it's going to keep going left past 10, past 100, past, keep going. Sorry, negative 10, negative 100, negative 500, negative 1,000. It's just going to keep going, but that way. X is greater than or equal to 0.
And the bracket 0, comma, and then it would just be positive infinity parentheses.
Before we do some others, look through just this section. Find any others you want to see, do go over, look challenging, want to clarify, have a question on. So, negative 3/8. Did you say one? Okay. So even though it has a fraction, the notation is the same. So where would this start if it's less than or equal to?
Negative infinity.
Ends at negative 3/8. Would that be a bracket or a parenthesis?
Parentheses. No.
Because of that less than or equal to. Any others in that section? Okay. I'm going to write in a couple, make up a couple. And this will help us with some of the ones below. Sometimes you'll have something that's between two numbers, and it will look something like negative 2 less than x less than or equal to 4. I'll write that somewhere on your paper so you have it to refer back to. So when it's written like this, we know the starting and the ending point is going to be the two numbers. We just have to figure out the symbols. Would it be parentheses or brackets or a mix, and how? So it's going to start at negative 2. This one's strictly less than, so it would be parentheses. Would 4 be parentheses or bracket? Bracket. So I'm going to change this so that the signs are switched. How would I write this one?
Wouldn't it be bracket? 4.
So knowing which one has the parentheses, which one has the bracket, or do they both have parentheses, both have brackets? That would be a strictly less than for both, or less than or equal to for both. When it's between two numbers, the symbols will always be either less than or less than or equal to. There won't be greater than in those type of numbers. Questions on that? So then let's go to this next section. So now we're given interval notation. We have to write it in set builder notation, what we were just seeing. So we'll do a few of these. So starting with this first one, negative 6 to 4. They're both in parentheses. How would we write that?
Wouldn't it be
So we're going to start with the number first, so negative 6, and then less than, yes, x. And then our next sign, would that be less than or equal to? Less than. Just like that. For the next one, if it starts at negative infinity and it stops at 5, is that less than 5 or greater than 5? Less than. And would that be strictly less than or less than or equal to? Strictly less than, yes. So x is less than 5. So how would we write that one? How would we write the next one? Less than or equal to x. Strictly less than 2. Correct. How would we write the next one?
negative 3 is less than
Strictly less than? Less than or equal to?
x, which is less than or equal to 3.
The next one is similar to the negative infinity to 5. How would you write that one?
8 is less than or equal to x.
Is it less than if it keeps going towards positive? Greater. and then it is equal to, but x is greater than or equal to 8. This next one I'm going to give you, because you may or may not know this. So x, there's a weird e, do it as best as possible, and then it's a double R, it's like a capital R with another line. Do it to the best of your ability. It's read as x is an element of all real numbers. You've probably seen me write that before. It just means the same thing as this. From negative infinity to positive infinity and everything in between. Let's skip to 3-5. How would you write that one? Are there any others in that section you want to see, go over, do, have questions about? If not, go to the next page. So now we're going to be using those intervals to help us find domain and range, increasing, decreasing values, and constant values on a graph. And we're going to talk about this. This should also say forward. So what this says for number 1 is really to help you visualize where are the starting and stopping points. So the ceiling or the roof would be the highest point on the graph. It doesn't go past this point. The walls would be like left and right. It does not go past this point. And then the floor would be, that's the lowest point. It doesn't go past that. So for this first example, 1, you have to realize that this has arrows, not points. So if we're talking about the ceiling or the roof, if the arrows means it's going to keep going up, you don't have a ceiling.
So would it just be positive infinity?
When we talk about range, yes, it will be. So we're not going to draw a line there. The floor, we do have a lowest point. It does not go past this point. But the walls, you kind of have to imagine this. This is going to keep going up and left and keep going up and right. So there's really no place to stop them. They just keep going. So we're going to do the range first and then talk about all the other ones. I'm going to highlight the x-axis to kind of help me see numbers. If you want to do that, I do have highlighters back there. And the order that these are in, you don't necessarily have to do, but you can. So range, we're looking lowest to highest. So where is the lowest point on our graph? -2. So it's going to start at -2. I'm going to write them in both types of notation. This would be a closed circle, so that would be a bracket. And then the highest point is positive infinity. So we could write it like that, or in set builder notation, because it's range, we're not dealing with y values, so that would be everything above -2, so greater than or equal to -2. Questions so far?
So if the write down,
Yeah, we would switch it. Like the second example, we're going to be doing that. Now for the domain, we're looking at furthest point to the left, furthest point to the right. So if this keeps going up and left, do we know what the furthest point to the left would be?
Negative infinity.
Negative infinity, it would keep going. Whoever said no. So that would be where we start. What about to the right?
Positive infinity.
So then negative infinity to positive infinity, or x element of all real numbers. The increasing, decreasing constant, that's where it gets a little tricky. Because we have to compare the x's and y's, but we're only writing down the x values. So, for increasing, we're looking at, as we are reading this left to right, where are your x values going up and your y values are also going up. So as I'm reading this left to right, I see at 3, I'm going to draw a line here, my y values start to go up as my x values are going up. So my interval is going to start at 3, and then it's going to keep going to positive infinity. Questions about that so far? So the arrows I drew on the function, you don't have to do that, but if it helps you visualize and see it, go for it. Decreasing is then the opposite. As your x values are going up, you're looking for where your y values are going down. You kind of have to ignore some of the stuff on the graph, because even though this has an arrow going up, I'm not focused on that. I'm looking at, as I keep going to the next x value, what is my y value doing? So when my x is 0, y is at 4, when x is at 1, y is at 2, when x is at 2, y is at 0, so it keeps going down that way. So it would decrease from negative infinity until it gets to that line at 3. What's nice about increasing, decreasing constant is that they should connect. So wherever it stops doing one thing, it should start doing the next, and then so on and so forth. Because it decreases from negative infinity to 3, and then at 3 it starts increasing, there's no room to be constant. But we'll do an example that is constant.
I'm still confused on why you said you start increasing at 3. Why 3?
So at 3, because I'm looking at my x values compared to my y values, at 3, my y values start to go back up, whereas before 3, they were going down. Does that part make sense? X-axis comparing it to the y's, yeah. Other questions on that one before we do another? Let's do this next one. You may want to draw over this. It's kind of hard to see. This does have arrows at the end. And there are numbers here, but they're just really, really small. I'm not even sure if that's actually what it does, but sure, just go back. So let's draw in ceiling, floors, walls first. Does this have a highest point in the ceiling?
2.
So when x is 2, when y is 2?
Like, oh, no. 0, 0.
0, yes. So your graph does not go above that point, so that would be like the ceiling, and you don't have to draw in these lines, it's just if you want to, if they help you. Does it have a floor, a lowest point, that we can draw? Correct. What about walls? If this keeps going down and left and keeps going down and right, do we have somewhere we could draw in that it stops? So then let's talk about our range. What would the lowest point be? Negative infinity. And it stops at
0.
0. So how would we write that in set builder notation?
Y.
It would be y, yes.
Y is greater than or equal to negative infinity. Or less.
It's going to be based on 0. So it would be less than or equal to. Because it's below. For our domain, what's the furthest point to the left?
Negative infinity.
If you don't know what it is, it keeps going. What about furthest point to the right?
Positive infinity.
Also positive infinity. You can kind of think about this like a little bit. So all row numbers. So then when we're looking at where is this increasing, I'm going to say it like this. Between 0 and 1, are your y values increasing as you're reading left to right?
Yeah. Wouldn't it be like 1.5?
Yeah. So I don't know what it actually is, but we can call it 1.5, sure. So it's going to start at some negative infinity and stop at 1.5. Would be everything left of 1.5. And then where does this decrease? Where do your y values go down as your x's keep going up?
2.
We could actually start at the same point, but at 2 it is definitely decreasing to where?
Positive.
Positive infinity. So negative, positive 1.5 to infinity, or the opposite of what you just did. So it increases from negative infinity to 1.5. Then at that point it switches and now it's decreasing. So there's no room to be constant for this one. What questions do we have on that one? We're going to do this next one. So if we're drawing in our floor, ceiling, walls, all those things, do we have a lowest point we can draw our floor at? It keeps going. I'm going to outline this also. What about a ceiling? Do we have a highest point we can draw a line at?
Keeps going.
Keeps going. But we do have a wall that stops here or starts here. And then it keeps going to the right. So for our range, what would be our lowest point?
Negative infinity.
And the highest point?
Positive infinity.
So they've changed places. So now y is going to have to star. For our domain, where does it start?
Negative 4.
And where does it end?
Positive infinity.
Or everywhere above or to the right of negative 4. So then increasing, decreasing, constant. Let's look at this top half first. Are these y values as you're going left to right, going up or going down? for the top half.
They're going up.
Yes. So we would say it's increasing starting at -4 to the right, so kind of like the domain. Like the domain, they're the same. But what's weird about this one is decreasing is similar because it's not really a function. So for these values, what's happening to your y values?
Decreasing.
Yeah. So it's decreasing and increasing at the same time on the same values, which normally does not happen. So in this one, we don't have anything before -4, and then everything after that is increasing and decreasing at the same time. So you don't have any constant. Questions so far? Mm-hmm. So for this one, let me back up. So these two had starting or stopping points, lowest or highest points, whereas this one did not have that. It's going to keep going down off the graph, and this one is going to keep going up off the graph. So there's no starting or stopping point for the range. Like if this were on Desmos and I zoomed out, it would just keep doing this forever and ever. I will attempt to find one that does that. I can't graph it like this. That's not a function. Of the bottom ones, pick one of those. The first or the second will be one of those. The first, okay.
Yeah.
So there is an open circle at the bottom and a closed circle at the top. This one, these bottom two do not have domain and range, but it is good practice to keep doing that. So if you want to do that on your own, you're welcome to do that. So of these two, where are your y values going up as your x values keep going up?
-2.
Mm-hmm. I'm going to draw a line there. It's going to start at -2 and then it keeps going to the right for infinity. Because this one is open, that would be a parenthesis. Is there anywhere where your x values are going up and your y values are going down? No. So there is no decreasing for this one. And then in this case, as I'm reading this left to right, what's happening to your y value?
It's staying the same.
Yeah, that's when it's constant. It's not changing as your x values keep going. So where would that start?
-2. Or negative infinity.
Negative infinity. It would end at -2. And that one is closed, so we can make that one a bracket. So the constant will only be where you see a straight line. What questions do we have on that? Two.
Why is the decrease not part of the line underneath the x-axis?
Okay. So we're not looking at where your y values are negative or your x values are negative. It's just as you're looking left to right. So if I start here and I'm going to the right, what are your y values from here to here? Right. That's why it would be increasing. So you're always comparing, but it's always based on what are your y values doing as you keep going to the right. So then for the remainder of class, you have options. You can go back and do the problems we did not do. These are examples that I thought were good examples on the following practice problems. So the first 4, I believe, are domain and range. The last ones are increasing, decreasing, so you could be working on any of those. You could do the 2 Khan Academies. One is on domain and range, one is on increasing, decreasing, so you could practice that. Get that done, out the way, use your notes, get help if needed. Be working on any of that. If you need to finish a test and want to do that now, you can come see me to work on that. Use this time wisely. Let me know if you have questions.
So could you create a past question?
Yes, I would.
Hoping for both.